I guess what I wanted to do today is just tell you a little bit about blockchains, sort of give you an high-level overview. I kind of kept it at a fairly high level, but if anybody wants to ask, kind of dive deeper towards the end, feel free to ask, and I'm happy to go into as much depth as you'd like. I have to say, I gave this talk to the alumni a few years ago, and I remember that at the beginning of the lecture, everybody was kind of like, what is this blockchain thing? I don't really get it. Maybe some of you have this feeling right now, and hopefully by the end of the talk, you'll have a better understanding of what they're about. Before we get started, I wanted to just tell you that I've been teaching a blockchain class on campus now for many years, since 2015. The class, the attendance in the class literally goes up and down with the price of Bitcoin. Yeah, literally. So this year, the class is actually fairly large. It's about 250 students. I worry that if Bitcoin doubles again, I'm going to end up with 500 students. And pretty soon, the whole campus is going to be taking it. The reason I put up this slide is I wanted you to be aware that everything in the class, all the materials are available online. If you want to go much deeper into this topic, just go to cs251.stanford.edu. The homework assignments, the programming projects are all available. Go have fun, do the homeworks, do the projects, do the reading materials, and there's a final exam at the very end, which apparently I'm not allowed to give today. So no quizzes at the end of this lecture. I have to tell you, this is actually one of the hardest classes I teach because this field moves so quickly that literally it's a new class every year. This is not like teaching calculus. I literally have to kind of design the entire class from scratch every year, which makes it really interesting for me, but it's also quite a bit of work to do. Okay, so let's dive right in. So what are blockchains for? So at a very high level, the way to think about what blockchains enable us to do is basically it provides a way for a large group of people to coordinate when there is no one you can trust. Yeah, so without a single trusted party. In the physical world, when people want to coordinate, we use governments for this. These days we use Google for this, right? But these are all trusted parties. And the question is, how do you coordinate when there's no single party you can trust? And that's exactly what blockchains are for. I can tell you that if you are looking at applications where people tell you, oh, we're going to use a blockchain for application X, the first question I want you to ask is, why can't we just have a central party do what it is you want to do? And usually the answer is we can't do it because there's no one we trust. But if there is someone that we trust, then in fact there's no need for a blockchain. And in the world of finance, actually often everybody's out for themselves. So in the world of finance, actually there is no trusted party. And that's why blockchains are actually a very good match for finance, although they're a good match for other things as well. So today, we're sort of 12 years into the blockchain revolution. It's still very young. This started in 2009. It's still a very young field. There's a lot more to do. But we've sort of identified 4 areas where blockchains are a tremendously good fit, and they've been very successful at so far. I already mentioned finance. I'm going to talk about finance. This is what's called DeFi, decentralized finance. So I'm going to talk a little bit more about that in a bit. Basically, what blockchains allow you to do is kind of create new financial instruments. In fact, if I could give you a homework assignment, I would literally ask you to go home tonight and design your own Solidity contract with a financial instrument of your choice. It's literally anyone can create a financial instrument using blockchains. So we can build what are called exchanges, lending, interest, insurance, many different things you can do using blockchains in the world of finance. Turns out blockchains are also extremely good for managing digital assets. The technical term for this is non-fungible tokens, or NFTs, but really these are digital assets. Here's an example of a digital asset. This is called CryptoPunks. I'll tell you more about CryptoPunks in just a minute. It's really quite an incredible story. I will let you guess maybe in your head, how much do you think buying this CryptoPunk costs? $6 million. Wow, $6 million. That's exactly right, actually. Good call. This guy costs $6 million, and we'll talk about why that's the case in just a minute. Turns out blockchains are also very good for gaming assets. So if you have a particular weapon that you like or a skin that you like in your game, you've worked really hard to achieve a certain goal in your game, you can record that on a blockchain, and it turns out, again, that's a very good fit. We'll see why in just a minute. Here is an example of horses that you can buy a horse and then race it against other horses and see how well your horse does against other. You can actually breed your horse with other horses and make new horses, and then you can buy and sell those horses. And again, all ownership rights here are recorded on a blockchain, so no one can take your horse away from you unless you give it away. This is the property of a blockchain, right? And finally, the fourth area, which is, again, a very good application area, is what are called decentralized organizations. In the physical world, in the US, these will be called partnerships. But it turns out partnerships are much easier to manage on a blockchain. And so these four areas are typically, are currently kind of a really good fit for this technology. Hopefully more areas will come along, but these four we know are working today, and they're actually quite large. So I wanted to just give you a quick timeline for how this technology developed, and for each timeline, like what is the fundamental new thing that the development enabled? Like, why did it happen now? Why did it not happen 20 years ago or 30 years ago? So if you remember, in 2008 we had the financial crisis, where a lot of currencies kind of tanked around the world, and people were kind of losing faith in the existing financial system, and in some sense that drove the development of Bitcoin. Which is a stored value system for potentially storing your assets. But there are some key innovations that enabled Bitcoin. And what I want you to understand is, like, Bitcoin gave us something that we simply didn't have before. So the new capability that it gave us, in very simple terms, is what's called a public append-only data structure. Yeah, so it's a ledger that you can write to. Anything you write to will never be removed. It will always stay on the ledger. And it's public. So anyone can write to it. Anyone can read from it. Anything you write to it will never be removed. And you should be asking me, well, how is that possible on a computer? Right? On a computer, you can always delete stuff. So how is it that you build a ledger that stuff cannot be removed from? And the answer is, well, again, you see why this is a little surprising. This is kind of a capability we simply didn't have before, like a ledger that you can write to, and no one can remove anything from it. Not the US government, not the Chinese government, no one can remove things from it. So why is this, so first of all, how do we achieve this? The answer is we achieve it by replication, okay? So the data in this data structure is replicated all over the world many, many, many times. And if you're going to remove anything from the data structure, you're going to have to basically remove it from a majority of the replicas. And presumably, that's difficult. So it's managed by replication and by incentives, so that the people who run the blockchain are incentivized to never remove anything. All right? So that's kind of a new capability that we didn't have before at a very abstract level. Once you have this capability, you can sort of see that you can build a financial system on top of it. Because if I pay Adam $5, Adam wants to make sure that transaction can never be erased. So his $5 will belong to him. I can never take those $5 back. Right? This is why you want a ledger. This is why ledgers are used in finance. And so it's not so surprising that once we have this capability, we can build a currency on top of it. In particular, we build Bitcoin, which is a fixed supply asset. Again, think 2008, lots of inflation, lots of local currencies were inflated to cope with that financial crisis. Bitcoin came along and said, this is an asset that cannot be inflated. Yeah, there will always be, there's an upper limit of 21 million Bitcoins that will ever exist in the world, and you can never go beyond that limit. This asset simply cannot be inflated, and of course that enables digital payments and much more. But this was just the beginning. This was 2009, created a lot of excitement. This is kind of where I got interested. This, for me as a cryptographer, this was amazing to see this being used. But there were lots of innovation, by the way, after. The next big step is, I would say in 2015, this is when Ethereum launched. So Ethereum took it to the next level. Ethereum is not just a ledger. Ethereum is a full-fledged computer. This is what we call a blockchain computer. Many of us like to think of this as sort of the next evolution of computing, right? You know how we went from mainframes to laptops to cell phones to clouds. Many of us like to think of the blockchain as sort of the next evolution of computing, the blockchain computer. And by the way, in my class, when I teach this stuff, you can see it's like when we program the blockchain computer, it's a really different way of programming than the usual way we program our laptops. It's just a fundamentally different model of programming. And so this is a fully programmable environment that can manage huge amounts of assets. Yes, all of a sudden we have code, very short programs, like 600 lines of code, that can manage incredible amounts, large amounts of assets. These programs actually, as I said, they can manage financial assets, as we'll see in a minute. And the other interesting thing is that everything is composable here. These programs can run on the blockchain, and they can call one another. So if somebody has a good idea and they write something, other people can call that and take advantage of that good idea. And again, we'll see all that in more detail in just a minute. So Ethereum basically enabled the growth of this whole DeFi and NFT world, decentralized finance and digital assets, to the point where today this entire ecosystem is evaluated at $2.4 trillion. 2.4 trillion, it's a lot of money. It's a lot of assets. By the way, I should say, nothing I say here is in any way any form of financial advice, but potentially, there's probably more room for this to grow. So let's go back to the basics. Okay, so before I get into the application areas, it's really important for me that you guys understand what a blockchain is and how it operates. Okay, and then we'll talk about the applications and why they are needed. So I want to go through this very quickly. I want to focus on applications, but I do want to go quickly through how blockchains actually work. So I think of a blockchain as a system that contains 4 layers. The bottom layer is what's called the consensus layer. This is what makes sure that all the replicas are consistent. You see, once you start replicating data structures, you have a problem with the replicas might be inconsistent. Like one replica might say, oh, I sent Adam $5. Another replica might say, oh, I didn't send Adam $5. Now what do we do, right? So there's sort of a consensus layer that ensures that all the replicas of the data structure all over the world have exactly the same data. On top of it, we build the blockchain computer. Yeah, so we'll talk about how that works in just a minute. On top of, by the way, these two together is often what's called a blockchain. On top of that, we have applications running on the computer. This is what all of us can write. So literally, you can go home tonight and you can write an application that will run on the Ethereum computer. These applications are called DAPPS, decentralized applications, DAPPS. So sometimes they're called smart contracts. The term I'm going to use is a DApp. I don't like to use the word contract, because if there are any folks here with a legal background, the word contract tends to confuse you. Yeah? So think of these as decentralized applications, and I'm just going to use the word DApp for applications that run on the Ethereum blockchain. So anyone can write a DApp, anyone can deploy the DApp, and finally, there are basically user-facing tools. There's like user interface that allows end users like me and you to interact with dApps that are running on the blockchain. Okay, so there's kind of the 4 layers of a blockchain. Let's start with the consensus layer. So as I said, at the fundamental level, what the consensus layer does is replicate a data structure that provides the following capabilities. The first one is called persistence, which means once you write something to the blockchain, it can never be removed. This is like a fundamental axiom of blockchains. Yeah, you need to this is like if there's one thing I can get across is that once anyone can write to the blockchain, and once it's written, it will never be removed from the blockchain. So presumably, in 100 years, in 1,000 years, the data that you write today will still be available. In fact, I'll tell you that you can see some transactions written to the Ethereum blockchain where it says, I'd like to welcome my baby girl to the world on this and that date, right? Somebody wrote this birth announcement. That birth announcement now will stay on the blockchain forever. Yeah, that's what you can do with it. Consensus means that basically all the replicas see the same amount of data. We talked about this. Liveness means that the system doesn't get stuck. You can always add new transactions. And finally, there's this property, which I'll call here censorship resistance, which means that anyone can write data to the blockchain. You see, if I send Adam $5 on the blockchain, and then he for some reason is not able to issue any transactions on the blockchain, he can't spend the $5. So it's as if I sent him nothing. Right? So it's really critical that these systems be censorship resistant. So if I give someone an asset, they should be able to use that asset by writing more data to the blockchain. So one of the important properties is that in fact anyone can write to the blockchain, and you cannot be prevented from writing to the blockchain. Again, the goal is, the Googles, the Facebooks of the world, they cannot prevent you from writing data to the blockchain. That's what the consensus layer does. And I want to quickly show you how this works, because there's a very cute idea that was introduced in Bitcoin for how to pay for all of this. Okay, so here's the blockchain. Here we have a collection of miners. The miners are the people who actually run the blockchain. The new name for miners, by the way, is validators, because miners have a, I don't know, unfriendly eco image associated with them. So these days we call them validators. In fact, I'll tell you, there's a very, very pretty blockchain that's designed to be green. I won't talk about that much unless you want me to, called Chia. That's a very green blockchain, and in Chia, the miners, the people who run the Chia blockchain, are actually called farmers. Yeah, so again, a very eco-friendly notion. But anyhow, we'll call these validators. These are the people that run the blockchain. And then there are the end users that actually hold assets on the blockchain. These end users, by the way, have secret keys, and these secret keys are the ones that are needed to make use of a particular asset that they hold. So these end users basically prepare transactions. They sign the transactions to say, I authorize this asset to be spent. Like, I authorize $5 to be sent to Adam from my account. These transactions are sent into the network. One miner is chosen. These are called a leader, right? So a validator is chosen. The validator creates a block, and then he posts the block onto the blockchain. And because he did that, he created a block of valid transaction, he gets paid 2 ETH. ETH is the currency of the Ethereum network, okay? In Bitcoin, he would be paid a certain amount of Bitcoin. Yeah, but in Ethereum, he's paid 2 ETH, all right? Then the next set of, and then all the other miners verify, all the other validators validate that this block is valid, otherwise they throw it away, all right? So that's one block. Then the users have more transactions they want to post on the blockchain. They send it to the network. Another leader is elected. He creates the block, and the block is posted to the blockchain. And this process continues over and over again, and this is how blocks get written to the blockchain. So this is how transactions get written. Now, you notice these miners are compensated somehow for their work. Their work is, they basically validate transactions, and they are the ones who put these blocks together and propagate them to all the replicas of the blockchain, right? They're doing work. So somebody has to compensate them. And you can see they're compensated 2 ETH, and you should ask me, these are called, by the way, the block rewards. The block rewards is what you get for creating a new block. So the question is, where is this money coming from, right? How are they compensated? And this is actually a really cute idea that the Bitcoin network, Satoshi, the creator of Bitcoin, came up with. The idea was the way we pay the miners for their work. Like here, I wish I wasn't like I could pause and have you guess, but I'll just tell you. The place where these 2 ethers come from is literally by inflation. Yeah, so we simply create 2 ether out of thin air. So now the number of ether in the world just went up. Yeah, same thing as in Bitcoin. Block rewards just create new Bitcoins. They just appear out of thin air, and the number of Bitcoins in the world went up. What does it mean the number of Bitcoins went up? By a little bit, right? Only by 2 ETH. What does it mean that it went up? It means that each ether is now worth less than it did a minute ago, right? So in some sense, the validators are compensated for their work by taxing the entire blockchain ecosystem, which is very interesting. You don't pay directly for the services. Well, part of it you actually do, but most of the payment that the miners get actually comes from inflating the currency. So this is a very creative idea that really allowed this to flourish and grow quite well. The transaction volumes on these networks is enormous, right? In Bitcoin, every day, every 24 hours, something like $30 billion change hands. Yeah, something like 400, 500, 500,000 Bitcoins change hands. On Ethereum, $16 billion every day change hands. Even on the smaller networks, these are more recent, more scalable networks. Even on these networks, you can see $2 billion or $1 billion change hands. So the volume on these networks is very high. There's a lot of trading activity that's going on. The other interesting aspect of this is, I imagine many of you have heard of cloud computing, where, in fact, most of the applications that most of us run are running in the cloud. Like if you have a Netflix account, Netflix is an Amazon customer, the whole Netflix application runs in the Amazon cloud. If you use Slack, if you use Gmail, if you use Salesforce, all these applications basically run in the cloud. In the traditional cloud, this would be running on the Amazon cloud, the Google cloud, the Microsoft cloud. Traditionally in the cloud, the developer is the one that deploys the application. The developer is the one that pays the cloud fees. So Netflix pays Amazon for the privilege of running the Netflix application in the Amazon cloud. If the developer fails, if Netflix goes out of business for some reason, the application will go away. You understand this, right? If Slack, for some reason, goes out of business, nobody can use Slack anymore, because now nobody's running the Slack application in the cloud. This is just the traditional cloud model. The blockchain world is very different. Again, the developer deploys the app to the blockchain. So here are names of some very famous apps that are running on the blockchain. What's interesting is because of this inflation mechanism, the community and the users are the one that pay the fees. It's not the developer. It's the community that pays the fees. And as a result, if the developer goes out of business, if Uniswap goes out, the company, Uniswap goes out of business tomorrow, it doesn't matter. The Uniswap application will continue to run. So applications that are deployed today will run forever, even if the developer is no longer supporting the application. It's a very different model from deploying things on a traditional cloud. Is that clear? I mean, there is a very strong parallel between blockchains and clouds, but it's just a fundamentally different economic model. Yeah, we pay our cloud fees, we pay the operators by inflating the currency, not so much by paying them directly. There's also direct payments, but primarily they're paid by inflating the currency. Okay, so once we have a consensus layer, we can actually start writing programs. And they run on the blockchain computer. And so what I want you to understand about these programs is, remember, this is a public data structure. Anyone can read data on this data structure, and the data, once it's written, it can never change. So the way we run programs on this data structure is what we do is we write our code, right, the program code, we write it to this data structure. All these things have names, by the way, but let's keep it generic. So we write our program code to the data structure. The program has some state, some memory that the program manages, and all that is maintained on the blockchain. So because the blockchain is a public data structure, anyone can look at the code, and anyone can see the current state of the program and verify that this code does what they think it does. Yeah. So again, with Netflix, with Slack, with all the cloud applications, Netflix tells me that their app does something, but I have no idea. I can't look at the Netflix code. Here, this is fundamentally different. I can look at the code that's running in the cloud. It's all public, yeah? And I can verify that it does what I expect it to do. It's really refreshing, because when you talk to a blockchain project, they have no secrets. Everything is going to get public anyhow. Is going to be public anyhow. So they'll tell you everything that they're doing, all their secret sauce, all their clever ideas, clever algorithms. They'll tell you everything, because it's all going to be public anyhow. It's very different from talking to Apple or Google or Facebook, where they might be running proprietary algorithms. So we have transparency. What's even more important is we have complete public verifiability. You can look at the blockchain and see that the code is running correctly. Yeah, the rules of the code are completely enforced. So if I say there will only be 21 million bitcoins, that's enforced in code. That's not like, I promise you I won't print more than 21. No, that's enforced in code. And if you try to print more than 21, those transactions will be rejected. Okay? So again, this is kind of a very interesting way to write code. It's really, I kind of think of it as like brain surgery, in that you write code and you post it to the blockchain, and now anyone can look inside the code that you wrote and in the state of your application, and can see exactly what your code is doing and what state it's in. So again, very different way of programming. So the picture I have in mind is, again, we have this consensus layer. On top of the consensus layer, we run the blockchain computer, and the blockchain computer maintains a lot of state. This is kind of the state of all the applications running on this computer. This is now several terabytes of data. So there's quite a lot of state stored on the blockchain already. Then people deploy applications, DAPPS, decentralized applications on the blockchain. Then we use traditional cloud servers like Amazon or Google to actually interact with these DAPPS. So you as an end user, if you want to use Uniswap, you could talk to the Uniswap application directly, but most likely you'll be talking to Uniswap by talking to a cloud server, and then they'll be talking to Uniswap on your behalf. Okay, so this is the architecture that I want you to keep in mind. All right, good. So that's kind of my quick overview of how blockchains work. Yes, I'd be happy to. This would be a good place to stop and take questions, but maybe I should move on, and once I stop, I'll be happy to kind of take your questions on this. Let's talk about the applications. What is this good for? So I told you, remember, 4 areas. Yeah, so I want to talk about the 4 areas: DeFi, NFTs, games, and DAOs. Okay, so let's start with DeFi. So finance. The amazing thing here is that anyone can write code. This is called Solidity. You program these things in a language called Solidity. So anyone can write Solidity code. And if you can imagine a financial instrument, you can just, crazy derivatives, futures, whatever you can imagine, whatever you like. You can actually implement it fairly easily in a few hundred lines of Solidity code, deploy it, and then the public, if they want to use it, they can use it. If they don't want to use it, they wouldn't use it. It's up to the public. Yeah, but the point is that we are no longer beholden to Wall Street to create our financial instruments. Anyone can create a financial instrument. Yeah, I could literally assign a homework problem. In fact, the homework project in our class next week is exactly to do one of these instruments. And so, we're no longer we're no longer in a situation where only folks in Wall Street can create instruments. Anyone can run experiments. There are already standards starting to emerge. So ERC-20 is a very famous standard for creating what are called tokens that anyone can trade. And so ERC-20 is basically an interface. It's made up of 6 functions. That's it. If you support these 6 functions, you basically have an ERC-20 token, and then other people can start exchanging their token with your token. And then, again, the minting rules, the transfer rules, all that's controlled by code. Yeah, so you say, great, so there's a tool here where now anyone can start writing code and deploy it into the world. And it turns out, in fact, a lot of people have. Yeah, so there are a lot of projects going on in the space. I want to mention 3 in particular. So Compound is a remarkable project for lending. So if you want to borrow your, so let's say you have extra ETH, you can actually deposit your ETH into Compound. Other people will borrow it from that contract and from that DApp, and you'll get interest. They'll pay interest, and you'll get part of the interest on the ETH that you own. So if you have ETH, you wouldn't just, ETH again is the token of the Ethereum blockchain. You wouldn't just sit on it. You can give it out and earn interest on it using this protocol. Uniswap is an exchange. Like DAI is a very famous other token. If you have ETH and you want to exchange it for DAI, Uniswap is a contract that will let you exchange one for the other. Very, very clever math that goes into Uniswap. We can talk about that a bit later. And then the third one that I wanted to mention actually is DAI. So DAI is what's called a stable coin. Now, you guys know that I'm sure you've heard that Bitcoin fluctuates in value, Ethereum fluctuates in value quite dramatically. So the question is, how do you build a stable currency on top of an unstable asset? Yeah, and so that's exactly what DAI is. DAI is pegged to the US dollar. And you should ask yourself, well, how is it that you peg yourself to the US dollar if you are running on top of an unstable currency? And the answer is that the DAI DApp, the code that implements the DAI token, what it does is it collects assets from various users, from the public. These are called liquidity providers. So it collects assets, and it's going to pay them an interest for those assets that they give to the DAI contract. And to the DAI DApp. And what DAI does, what the actual code does, is if it sees that the price of DAI starts to go above $1, yeah, it's supposed to be pegged to $1. If it sees that the DAI price goes above $1, what does it do? It just prints more DAI. If you print more DAI, the value will go down back to $1. When it goes below $1, what it does is it will use the assets that it has in its bank, in its treasury, to buy back DAI from the public. Now there's less DAI in circulation, so the price of DAI will go up. Yeah, so it's, in some sense, you implement the rules of the Federal Reserve into a DApp, you deploy the DApp, you give it enough assets to actually control the exchange rate of the currency, and then you can have a stable currency. Now, I'm oversimplifying. This is a lot more complicated than what I just said, but at a high level, you can think of that's what it does. Yeah, so basically, we even have stable assets running on top of the blockchain. As I said, there are many, many, many fascinating projects in the space. What's amazing to me, what's kind of really exciting to me, is that literally each one of these programs, these are just programs, each one of these programs is just a few hundred lines of code. They're not complicated programs. You can go and read yourself how these programs work. And these programs, you can see they manage incredible amounts of money, right? Literally, these few hundred lines of code manage $16 billion, right? Running on the blockchain. So all these projects, all these programs are kind of running. Here's the Uniswap that I told you about. Its treasury right now is $7 billion. Those $7 billion are used to stabilize DAI. Yeah, that's what it's for. Here's Compound that I told you about. People give it funds, and it lends them out and collects interest. Its treasury is right now $11 billion, and so on. So you can see there's really quite a lot happening here. Quite a lot of people are interacting with programs in the space, so it's quite interesting. Now, I wanted to give you one example of how Uniswap works, but actually, I think in the interest of time, I'm going to skip this. If there's time at the end, I'll be happy to come back to it. It's a little bit of math, kind of pretty math, in how it actually works, but I will skip it for now and come back to it later. So one question you should ask me is, why is all this FI needed in the first place? We have Wall Street. right? Why can't we just rely on the traditional financial system? Well, it turns out the traditional financial system has some issues with it, let's say. Yeah? And I want to give you 3 examples. And I'm not even going to talk about the 2007 financial crisis, which, by the way, as you know, was caused by funny financial instruments that were created by experts, right? So let's talk about 3 issues with the existing financial system. The first one is cross-border transactions. Here, I went to wise.com, which is a way to send money anywhere in the world, and I said, I want to send $10 to Argentina. Now, they tell me, sure, you can do it, but this is the transaction fees we're going to charge you. So basically 36% transaction fees if I want to send $10 to Argentina. Yeah, very, very high transaction fees on small transactions to remote places. With blockchains, this basically goes away. Now, some of you might complain that blockchain transaction fees actually are high, but they're actually going to become pennies, like in the coming year or two. Yeah, there's a whole scaling project. There are many scaling projects that will bring down transaction fees dramatically. So with blockchains, these transaction fees should just not be there. So that's one thing. The second thing is, not all of humanity lives in the US where we have a stable currency. Some of us live in unstable economies. This is an article that was written by a Venezuelan economist who explains how Bitcoin completely saved his family because of during the collapse of the Venezuelan currency. I encourage you to read this article. It's very, very interesting how this works. Just Google "Bitcoin has saved my family." You'll find it right away. It's a very, very interesting article to read. So that's the second place where cryptocurrencies can help. And the third issue is what's called financial inclusion. You know that if people who don't have a lot of assets, typically, well, what can I say? Typically, banks charge fairly high transaction fees to interact with them. And again, this is an area where blockchains might help, because blockchains don't care if you have a lot of assets or little assets. Transaction fees are the same either case. The only reason I put maybe here is because interacting with a blockchain does require some computer literacy. And so, if we can kind of provide computer literacy to more people around the world, there's greater chance that blockchains will help with financial inclusion. And I would say that because of all these three categories of issues with the existing financial system, there's actually quite a lot of interest in cryptocurrencies from central banks. And maybe I'll tell you, I just wrote down some statistics here, that 81 countries representing 90% of the global GDP are currently exploring central bank digital currencies. China is the most further ahead. And which one do you think is the least further ahead? Well, so basically it says here, the United States is furthest behind. Yeah, so that's kind of the state of the world we're in. This is a little bit of a race, because whoever gets to create the first global currency, in some sense, could dramatically affect the financial system. Yeah, so there's pretty interesting things are going to be happening in this space in the coming years. That's all I want to say about DeFi. DeFi is I could talk for an entire course. In fact, we are doing an entire course just on DeFi, but that's all I'll say here. The next topic I want to talk about, I have 10 minutes, so the next topic I want to talk about is non-fungible tokens, digital assets. So this is literally every time I talk about digital assets and non-fungible tokens, NFTs, the public is very confused about this, right? These CryptoPunks, these things here, yeah, these are literally 24 by 24 pictures, 24 pixels by 24 pixels. I think the reason for the confusion is, why would anyone pay $6 million for 24 by 24 pixels? Yeah, is anybody not confused about this? Well, let me try to explain. First of all, there's a standard that's evolving around these digital assets. It's called ERC 721, which is, again, just a way to interact with it's just a way to make sure that these objects can interact with one another. Now, NFTs are way more than just these CryptoPunks. Yeah, NFTs, the way to think about this is basically a way to generally manage digital assets. Yeah, so for example, there's a lot of digital art that's being bought and sold through these NFTs on blockchains. There are a lot of collector items that are being bought and sold through these blockchains. One good example is called NBA Top Shots. So if you have a favorite NBA player, you can go to NBA Top Shots and buy a video of that player, dunking and succeeding in a game. Those videos, usually the more famous ones, they could be fairly expensive. And the interesting thing is, if you buy them, the player gets a cut of the fact that you bought the NFT. So it's a way for you to support the player that you're a fan of. Typically, the player will also interact with you. Yeah, it's really quite interesting to see. So in some sense, when you buy an NFT, you're kind of supporting the creator of the NFT, and you're creating a community. You're joining a community around that creator. Yeah. So not everybody buys them just because they might appreciate and value later on. A lot of people buy them because they just want to join this community. They want to support the creator. You might get perks, like if it's a musician, you might get invited backstage in a concert. If it's a journalist, you might get to see their articles before the public gets to see them. So there are all sorts of benefits that creators can give you because you bought their NFT. But also, it turns out, there are lots of games now that are built around these blockchains. And here, this is a picture of a very famous recent game. It's called Axie. So you can buy an Axie. Now, you own a character in that game, and then you can breed that character with other characters. And you can create new characters. They breed, they create another character. Now, you own this new character, and you can sell it to somebody else. Yeah, so you can actually, by interacting with the game, you can even potentially create more NFTs, which you can then sell. And then there's the whole concept of the metaverse, which unfortunately I won't have time to go into. The metaverse is sort of, there are a couple of marketplaces for metaverse right now where you can actually start to buy plots of land in a digital world, right? And people are buying these plots of land, and they're building things on it. Other people might come and visit them in their plots of land. Maybe they pay rent. So there's a whole economy that's forming around these NFTs. Again, this might look, well, let's say, if you're not used to digital assets, this might look strange to you, yes? But I will tell you that the way the world is going, digital assets are going to increase dramatically in value until at one point, our digital assets are going to be worth more and more important to us than our physical assets. This is just where the world is headed, and this technology is a way to manage digital assets. And remember the first thing I told you, always ask, why do this on a blockchain? Why can't we just centralize? Why can't we have Google keep track of who owns which NFT? So the answer is that the reason we don't want to manage this centrally is that the blockchain basically ensures that you have long-term possession of the item. No one can take it away from you until you give it away or sell it. So when you buy a CryptoPunk, I'll tell you CryptoPunks in just a minute, more about them. When you buy a CryptoPunk, that CryptoPunk will be yours until you sell it. If you want to, you can hold on to it and give it to your kids, and they can give it to their kids, and so on and so forth, yes? No one will ever take it away from you. If it was managed centrally by a company, if that company went out of business, you could lose all of your digital assets. Yeah, that's the danger. And so the reason blockchains are such a good fit is because longevity of the assets, there are no mistakes. It's not going to be the case where, accidentally we gave away your digital asset because we made a mistake. Mistakes are not possible on a blockchain unless you mismanage your secret key. It's all on you. And the other thing is it provides provenance. When you buy a Van Gogh, you have no idea if the Van Gogh you just bought is authentic, is it real or not. Here, there's no question. You have complete trail of the provenance of the NFT that you're buying, and you are guaranteed that it's the authentic one. So let's talk about CryptoPunks. This is an example, a very cute example. It's actually one of the first NFTs. Basically, there are 10,000 CryptoPunks. These are literally 24 by 24 pictures. There are 10,000 CryptoPunks. There will ever be only 10,000 CryptoPunks. Nobody will ever create any new CryptoPunks. There are only 10,000 of them. It's a very rare item. At this point, everybody in this community wants to own a CryptoPunk. It's literally as valuable as owning a Van Gogh, right? Just to give you an example, a few weeks ago I went to a blockchain event where somebody showed me that they bought a CryptoPunk. Literally, the admiration of the community around in that event, that, oh my God, you have a CryptoPunk, that's incredible, right? It's like literally the type of admiration you would get from owning a Van Gogh. Yeah? It doesn't matter that it's a 24 by 24 picture. The fact that it's rare, it was created in 2017, and none will ever be created again, is what makes it valuable. Okay? Just like a Van Gogh. Yes, that's the point. Okay, so here's CryptoPunk number 7610. Let's look at it. You can look on the blockchain and see exactly the record of what happened to it. So you can see that somebody claimed it on June 23, 2017. The creator of the CryptoPunks just gave them away for free. They just put 10,000 of them out. And here on June 23rd, somebody claimed it. Then, let's see, on June 30th, a week later, that person offered to sell it for $60. Yeah, let's see. On August 3rd, a few days later, somebody bought it. Somebody agreed to buy it, and here it transferred to GR8WXL, and GR8WXL is now the owner of this CryptoPunk. Then, later on, GR8WXL offered to sell it for $3,000, and here, this person bought it on May 5th, 2021 for $3,000. Okay, very good. Oh, 31,000. Yes, thank you. Yes. 3,000 would have been a bargain at that point. And then, let's see. So I'm going quickly through the history. Then, basically, somebody made a bid. So there's a buy offer on August 18, 2021. There's a buy offer to buy it for roughly $150,000. And in fact, the owner at that time, G-Money, agreed, and this was purchased by 0xA04E64. Does anybody know who 0xA04E64 is? So this is not a household. Somebody said something. Visa, very good. Amazing. So I was going to make a joke that this is not yet a household name, but I guess it is a household name. And in fact, this is Visa. The company Visa bought an NFT to show that this is an important area. They're getting into the space, and they want to be a part of it. And this is the amazing, this is like what? This is like 3 or 4 months ago? And the amazing thing is that after Visa bought it, like literally a few days later, somebody else made a bid for $500,000 to buy their NFT. But Visa didn't sell it. I think that's like a week or two ago, or maybe 3 weeks ago, there was an offer to buy one of these CryptoPunks for around $9 million, maybe it was $11 million. And the person, $11 million to buy a 24 by 24 picture. And the person who owned it said, no, I'm not selling it. Right? People you have to understand that when you own a CryptoPunk, this becomes people change their name to, 2551 because they own CryptoPunk 2551. This is like a big identity issue for people. I mean, you may find it odd, but it is a big deal. It's literally like owning a Van Gogh, where your whole identity is now wrapped around the fact that you own this Van Gogh. Yeah? And so that's kind of the phenomenon. All right. So there are a lot of issues with ownerships. Like, for example, if you buy a YouTube video as an NFT, who gets the ad revenues that YouTube video generates? Yeah, there are interesting questions around that. Turns out it depends on how the NFT is actually implemented. Where is this stored, and so where can it be displayed? All that depends on the actual NFT code. I can tell you there are marketplaces for these NFTs that are trading them, doing quite a lot of volume in trading NFTs. So it's quite interesting. And the other thing that's happening is the world of NFTs and the world of DeFi is starting to merge, in the sense that if you own an NFT, you can use it as collateral in loans. So you can use your CryptoPunk as collateral to now buy a house and get a mortgage, right? You can actually do fractional ownership of an NFT. You can actually build a whole NFT-based futures market. You can sell derivatives on your NFT. Yeah, so there's an entire financial market that's evolving and being created around these NFTs. So very interesting. All right, so the last application, I'm at 4:15, but I really want to say a few things about DAOs. So the last thing I'll tell you is about decentralized organizations. Basically, what a DAO is again, it's just a program running on the blockchain. It's just a program. Yeah. Now, anyone can send funds to this DAO, anyone in the world, right? If you have a computer and an internet connection, you can interact with these DAOs and send funds to the DAO. And you could join the DAO community by sending funds to the DAO. Then people can submit proposals for what to do with the DAO treasury, and the participants of the DAO can vote on those proposals. Right? So this is why I said it's like a partnership where all the partners contribute, and then together they decide what to do with the treasury. And so there are DAOs, for example, for collecting art. Yeah, so you want to support artists, so there are DAOs that formed to collect arts. There are charity DAOs, right? They want to vote on what they give, what they donate to charity. There are investment DAOs. There are many investment DAOs, actually. Together, they decide what to invest in. In the future, you can imagine, if one of you has an idea for a movie script, you can go to a movie DAO and say, hey, I have this idea for a movie script. I want to make a movie, but I need whatever a movie costs. I don't know. I need $10 million to make the movie. And the DAO will vote based on your script. The members of the DAO will vote on whether they want to fund you or not. And if they fund you, you get your funds and you can go ahead and create the movie. So you can see we can have like film studio DAOs that might be much more efficient than the existing film studios. So that's kind of where DAOs are heading. Creating DAOs is really quite simple. Again, you can play with syndicate.io. As a homework assignment, go home tonight and go create your own DAO. Yeah, go to syndicate.io, create your own DAO, and who knows, maybe if you have a good idea for the DAO, people will actually start to participate in the DAO community that you created. So Pleaser DAO is an example of a DAO that invests in art. Its treasury right now is $26 million. Gitcoin is a DAO that supports open source projects. They already supported projects to the tune of $36 million, and like I said, there are many investment DAOs. One might wonder about regulation. Yeah, so I'm sure some of you are thinking, how is all this stuff regulated? And this is where things get, let's say, complicated, right? The reason it's complicated is because this is not restricted to a single jurisdiction, right? This is a global system. It's not clear which regulator has authority to regulate this, right? And so, or not just authority, or ability to regulate this. And so there's probably more regulation coming down the pike in the US, but that would only affect US users of these systems, not the rest of the world. And so how this will be regulated is going to be very interesting. Of course, nobody wants to, this is like seems like a growing market. I mean, it's a more efficient way of coordination and organization, so nobody wants to hinder it. But the question of regulation is actually quite interesting. The last thing I'll say is what I work on. So there are a number of hot topics in the space. For example, how do we scale the blockchain so that it can handle many, many, many transactions a second? How do we deal with privacy on the blockchain? So businesses generally don't want people to see the transactions they're making. So how do we allow businesses to transact privately? If Stanford wanted to pay my salary in a cryptocurrency, today everybody will see exactly what my salary is. How can Stanford pay my salary and keep my salary private? Yeah, that's a very interesting question. We have good answers to this. It's just a matter of more usage. And then there are multiple blockchains. It's not just all Ethereum. So there's this question of interoperability. So for example, suppose I'm sitting on Polkadot. I have 20 dots on the Polkadot system, and I want to use them on an exchange running on Solana, which is a different blockchain. The question is, how do I use my Polkadot money on the Solana blockchains? This is the interoperability question, and there's a lot of work on that as well. So because of this is a really exciting area. I've been working in this area now for many years. We actually, at Stanford, we created the Stanford Center for Blockchain Research, CBR. It's sponsored by sort of the top projects in the space. If you want to check out what we do, go to cbr.stanford.edu. We have a lot of activities. We do a lot of conferences and events and seminars and research. It's a very, very active community here on campus. We also have a blockchain club run by the undergraduates. So there's a lot of blockchain activity at Stanford. In fact, in January, we're running what's called the Stanford Blockchain Conference. It's going to be here at the Arriaga Center. It's going to be open to the public. It's going to be free. So if any of you want to learn more about blockchains, please come. We've been running this now for many years. It's always a fun event, and we do that to support the community and because we are just kind of excited about the technology and we want to see it continue. Thank you very much.